Something terrifying is happening right now. Multiple observatories confirm 3I/ATLAS has turned gold, the exact color shift that destroyed comet K1ATLAS just weeks ago. Both objects, same golden glow, same constellation, Leo. K1 fragmented immediately after. Now with 3I/ATLAS, just 4 days from its closest approach to Earth and showing identical warning signs, astronomers are asking, will this interstellar visitor survive, or are we watching the countdown to another cosmic breakup? Let's dive right in. Look at these images coming in from observatories around the world. December 10th, amateur astronomer Alberto Quano Vodnica captures something that makes him pause. 3I/ATLAS is glowing unmistakably gold. He's not the only one. December 14th, multiple independent observatories confirm the same golden hue. Then December 15th, Tony Schiaretta in Italy photographs it again. Same golden glow. This isn't one telescope having calibration issues. This is a real transformation happening right now. But here's what's sending chills through the astronomical community. Just 6 weeks ago, Comet C/2025 K1 Atlas did something eerily similar. It entered the constellation Leo, turned golden, and within days began tearing itself apart. Same constellation, same color, and now we're watching 3I/ATLAS follow the exact same script. When we first spotted 3I/ATLAS on July 1st, it wasn't subtle. This object blazed a deep dark red that immediately told astronomers something was profoundly different. The red color revealed heavy concentrations of organic compounds, complex carbon-based materials that had no business being there in such abundance unless this object had lived through something extraordinary. Then everything changed in late September, as 3I/ATLAS crossed what astronomers call the waterline. At 2.5 astronomical units from the Sun, it erupted. The transformation was dramatic. Suddenly, this red object was glowing brilliant green, flooding space with cyanide and cyanogen gas. It was like watching something wake from a million-year sleep, and what emerged was violent and spectacular. Now, just weeks after passing its closest point to the Sun, we're seeing gold. And this is where every astronomer studying this object is asking the same question. Are we watching the warning signs before another interstellar breakup? What happened to K1 Atlas isn't ancient history. This happened weeks ago. As K1 moved into Leo, observers started noticing the golden color developing. At first, there was excitement. Gold-colored comets are genuinely rare and beautiful. But then the fragmentation began, and it wasn't gradual. Large chunks started breaking away from the main nucleus. Within days, K1ATLAS went from intact to disintegrating. Now look at 3I/ATLAS. Same golden color, same constellation, same progression. The parallel is so precise that it's impossible to dismiss as coincidence. Something about this color change signals structural instability, and we're seeing those exact signals right now. To understand why this matters so much, you need to know what 3I/ATLAS actually is. The chemical fingerprints tell us a story that sounds like science fiction, but is backed by hard, spectroscopic data. This object was once a comet, but not around our Sun. It orbited a completely different star in a system light years away. It went around that star hundreds, possibly thousands of times. Each orbit stripped away materials, burned off volatiles, until what remained was a heavily processed core, basically a dead comet from another solar system. Then something violent flung it out into the void between stars. For millions of years, it drifted through interstellar space, slowly accumulating a thin layer of pristine material. Water ice, organics, exotic compounds created when stars exploded and scattered across the galaxy. When it finally wandered into our solar system, it arrived carrying this dual identity: a dead, processed core from another star wrapped in a thin crust of virgin interstellar material. That thin crust is what erupted when it got close to our sun. That's what created the green glow, the dramatic activity. And now that crust is burning away. When 3I/ATLAS first became active, spectroscopic observations detected massive amounts of nickel vapor in the gas surrounding it. What shocked astronomers was what didn't appear alongside it: iron. Nickel and iron are cosmic siblings. They're forged together in dying stars. They exist together in asteroids, meteorites, planetary cores. Finding abundant nickel without iron is like finding smoke without fire. It violates everything we understand about how these materials form. The explanation involves metal carbonyls. In carbon-rich environments, nickel can bond with carbon monoxide to form nickel carbonyl, which vaporizes easily and survives the journey from the nucleus into space. Iron carbonyl, however, is reactive. In the presence of water ice, which 3I/ATLAS has plenty of, iron carbonyl breaks down before it ever reaches space where we can detect it. This chemical signature is like receiving a postcard from another stellar system. It's proof that 3I/ATLAS experience chemical processes in environments we've never directly observed. When we first detected 3I/ATLAS on July 1st, it was already active. Most comets need time to warm up gradually. Not this one. It started out gassing almost immediately, which told astronomers the crust of interstellar material was incredibly thin, maybe only meters thick, maybe only centimeters in some places. Then came late September, and 3I/ATLAS crossed the waterline. At 2.5 astronomical units from the Sun, solar radiation becomes strong enough to efficiently sublimate water ice. When 3I/ATLAS hit that boundary, everything intensified. Vast reserves of water ice began vaporizing, carrying cyanide compounds and other volatiles trapped in the ice. The color shifted to brilliant green. By late November, observers at Gemini North Observatory started seeing the transition. Images showed hints of gold beginning to mix with the green. Through December, the green faded. Gold took over. The volatiles were depleting. Gold coloration tells us we're looking at dust reflecting sunlight, not gas emissions. The ices that created the green glow are running out. Those organics that gave 3I/ATLAS its initial red color were in the outer crust layers. As the object heated up, those organics vaporized and got carried away into space. What's left now is deeper material, reflecting light differently. This is exactly what K1 Atlas showed right before it fragmented. The gold color isn't just pretty, it's a symptom of structural changes inside the nucleus. As volatiles escape, they create voids, leave empty spaces, weaken structural integrity. Under thermal stress, these weaknesses can reach a critical point where the whole thing comes apart. December 19th is crucial. That's when 3I/ATLAS makes its closest approach to Earth at 0.85 astronomical units, roughly 127 million kilometers. More importantly, it's a new moon. The moon will be positioned with the sun, meaning the night sky will be dark. No moonlight to wash out faint objects. Perfect observation conditions. Astronomers worldwide are already scheduling telescope time. Amateur astronomers with serious equipment are planning early morning sessions. Everyone wants to capture what might be the last clear view of 3I/ATLAS while it's still intact. Because if fragmentation begins, it could happen fast. K1 showed us that. The stress patterns were already building. They just needed a trigger. For 3I/ATLAS, we're past perihelion now, but thermal effects don't stop immediately. Heat conducts inward, stresses build. Sometimes the breaking point comes days or weeks after maximum heating. Will it survive? The honest answer is we genuinely don't know. We're seeing every warning sign that preceded K1's fragmentation. The color progression is identical. The shift to dust-dominated emissions suggests structural changes are happening. The thermal stress from perihelion is still working through the object, but 3I/ATLAS has already survived perihelion. It's moving away from the sun now, receiving less thermal input every day. We don't know its density or internal structure. It might be more cohesive than K1 was. Not every comet that turns golden breaks apart. After December 19th, 3I/ATLAS will continue outward toward Jupiter, steadily dimming. By January, it'll be noticeably fainter. By February and March 2026, you'll need serious telescope power to see it. If fragmentation happens, we'll see multiple pieces, each trailing its own small tail. Spectroscopic analysis might reveal fresh material from deep inside, material that never saw starlight in its previous system. If it survives, 3I/ATLAS will eventually leave our solar system, heading back into interstellar space. The encounter with our sun will have changed it. Different trajectory, altered composition, but it will carry new materials picked up from our solar wind. 3I/ATLAS is only the third confirmed interstellar object we've ever detected. The first, Oumuamua, was rocky and inactive. The second, Borisov, behaved normally. Now, 3I/ATLAS is showing us something completely new. A thermally processed refugee from another stellar system wrapped in pristine interstellar material. These next 4 days aren't just about watching a light in the sky. This is potentially our last chance to study an intact messenger from another star system before it either tears itself apart or fades beyond detailed observation. Whatever happens, we're witnessing something rare, a visitor from the cosmic ocean between stars, and we're watching it either survive or die under our sun's light. So here's where we stand. In 4 days, on December 19th, 3I/ATLAS reaches its closest approach to Earth under perfect viewing conditions, new moon, dark skies, maximum visibility, and it's glowing gold, the exact color shift that preceded K1 Atlas's violent fragmentation just weeks ago. Will this interstellar visitor survive its encounter with our sun? Or are we watching the final days before it tears itself apart? The answer is coming, and it's coming fast. This is the kind of cosmic moment that doesn't happen often. An object from another star system, showing us chemistry we've never seen before, potentially about to fragment in real time. Whatever happens next week will rewrite what we know about interstellar objects. I'll be tracking every observation that comes in. If 3I/ATLAS starts breaking apart, you'll see the analysis here on Galactic Breaking News. If it survives, we'll follow its journey back into deep space. Here's what I need from you. Hit that like button if this story grabbed you. Drop a comment. Do you think 3I/ATLAS survives or fragments? Subscribe to Galactic Breaking News and smash that notification bell so you don't miss what happens during the December 19th flyby. This is developing in real time, and the next update could change everything. The universe just handed us a front row seat to something extraordinary. Let's see how this plays out together.